Hello, Omnic. Now, what is large? It depends on how large my monitor is. Why is this sounding so weird? Testing 1, 2. I don't know, something's wrong with how I sound. Oh, well, okay, Omnic, stick around, I'll show you in a minute. Well, I can already show it. No, let me first type this line. I'm gonna do like 20, and then if that's too large, then I guess I'll tone it down. Well, 20 is a bit too much, but I'll see. 3YY, and then another one for N2. And if yeah, I worked yesterday on it the whole day, and eventually I came up with this, which is, yeah, well, it's unreadable math, of course, but it's basically just the mathematical formula for K2. K2 being all odd positive integers that end in 1 after 2 Collatz steps. One Collatz step being multiplying by 3, adding 1, and removing all powers of 2. As you can see, it's simply, well, 2 to the power 3 times m1 plus 2 times n2. And then subtract 3 plus minus 1 to the power m1 times 2 to the power of 2 times n2 plus 6. And then all divided by 18. So it's really a straightforward mathematics formula. And I don't, do I sound normal? Because it sounds like my microphone is I don't know. Hello, testing 1, 2. I think my microphone is broken. Hello. Testing 1, 2. Test. I don't know, something is wrong. Testing 1, 2. Test. Ding. Test. I sound way more hollow. I sound okay? I had the feeling that normally I would sound less hollow. It's like, yeah, I wouldn't know what is wrong. Okay, so let's have a check here. if I run this, well, those numbers are almost the same. How much coincidence is that? Yeah, and I mean, normally I sound different. I had an absolutely excellent audio, completely dry and stuff, and now it sounds different. Don't get it. Yeah, I'll ask if you are a regular. Can you compare my sound not with how I usually or I used to sound? I'm not happy with it. It's really weird. This. No. Anyway. Yeah, it can. You would say it cannot really be the microphone. I don't know. Excuse me. Horrible. Why am I sounding like this? Not getting it. Now, this is really interesting because hello. Why do I? Oh, yeah, no prompt. If I multiply this with 3 and then add 1, I get that. And then we divide that by 2, and again by 2, and again by 2, and again by 2, and again by 2. I thought it was going to be... Oh no, I set it to 20, so I have to divide it 20 times probably. More or less. You'd say, why don't you try to divide it by 1024, but stupid thing doesn't do, what is it? Floating point. So I divide it by too much, it still looks like an integer. So for now I'm just going to do careful division. Would have been nice if this thing just printed it in hex or something like that. Holy moly, so much. How many powers of 2 are this? Don't tell me it's already at the end. That looks like a power of 2. For the first time I recognize it. Oh, it's 10 times. 5. Okay, this ends in 5. I keep dividing by 2. That is really strange. And this one is K1. I mean 5 is K1, so this is indeed K2. But I had expected something else than having to divide by 2 a gazillion times and then getting 5. It's just this one times 3 plus 1. gonna try dividing by 1024, and then I have to test if it multiplies. Yep, that gets the same thing. So divide this one again. That doesn't, that is a power of 2, isn't it? Well, it should be, so yeah. Yeah, so it's just a power of 2, so that is K1. It's very curious that they are almost the same. In fact, they are not the same. This one is 10 times that one plus 3. Okay, anyway, now I get it. I'm getting it. I'm using M1, which is one of the huge tricks here. And M1 is calculated by looping. So I set just N2 to some value. Then M1 is incorrect. Let me print the values of, let's see, M1. No, M1 is a function of N1. Bleep. Lost my music. Standard out. Let's print N1 and M1. I don't think there's a very neat formula for it. No, well, not a linear formula, but I'm lazy. I need a make. So we have this, and this, and this, and this. Yeah. Okay, how can I go from N1 to M1 in one step? Need to increment this one here to, let's say, 100. Not that one, that one. Big numbers. I think we get roughly in the neighborhood by dividing by 3 and then multiplying by 4. Divide by 3, multiply by 4, but it gets only in the neighborhood. So what if I do? Well, first of all, let's put it on a new line because we are somewhere in the middle. And then add the view star so I can really quickly see it. And then I'm going to assume that my approximation is something like M1 times 3. What was it? divided by 3. Divided by 3. Let's multiply with 2 first. And then I just subtract m1 to see the offset. What is that? What? That's not as bad as it looks. I just forgot to add another semicolon. Okay, so adding not clear. 3, 3, 3, 4, 4, 4, 5, 5, 5. Okay, so everything repeats 3 times. So that would be adding n1, I think. No. Adding n1 divided by 3. Yep. I'm gonna do m1 divided by 3. Add that. Okay, now we are pretty close. 0 minus 1 minus 1. 0 minus 1 minus 1. Where the 0 occurs when this is divisible by 3. Clearly have to use a different approach. I'm going to wait. What is the current formula of that? Instead, I'm going to multiply m1. No, multiply n1 with 3. Yeah. So this is my current formula. But instead, I'm going to print n1 times 3 so if this was a good approach, I would now have gotten this times 3 and this times 3 and this times 3. So that becomes a 2. Drop that one out. Oh, that's 0. Not a good idea again. No, not a good idea. No, let's try. And I meant m1. Did meant m1 times 3. Did I just make a formula depending on m instead of n? That's stupid. I'm going to delete this completely. And 1 times 3 minus n1 times 2. Let's see what the difference is. See, that's much better. Now we have 1, 2, 1, 2, 1, 2, 1, 2. It's different. So I subtract 1 from it, and then the modulo of 2. Subtract the modulo of 2. Minus 1 minus n1 modulo 2. Nope. Not getting it. Probably plus the modulo of 2 then. Also not. So what was I seeing then before I did this? Thought it was super easy. I'm really seeing 1 and then 2, 1, 2, 1, 2, 1, 2. I guess, no, you cannot guess. It's just 1, 2, 1, 2, 1, 2. To subtract 1, I must see 0, 1, 0, 1, 0, 1, no? And we do. 0, 1, 0, 1, 0, 1, 0, 1. Well, that 1 is really n1 modulo 2. I have no idea what I did wrong here. If I subtract n1 modulo 2, then it should become 0. And it isn't. It's only minus 1. What? What? How is that possible? Or is it m1 modulo 2? It didn't look right. Nope. It's not. This is the weirdest thing ever. Going back to this. Now I finally see it. Yes. I'm an idiot. I'm looking at it and I assume that n1 is incrementing 1 every time. But that's the whole thing, it doesn't. m1 increments 1 every time. So it is m1 modulo 2. But then the exact opposite thing. So I need to subtract 1 again, so that this becomes 0 and this minus 1, and then add the modulo 2 of m1. Finally. But that's not enough, because I need to solve m1. So now I have this equals 0. Or in a mathematical sense, just equals 0. And then I can add 2 on both sides. And then add 2 times n1. So this times n1 plus 1. Okay, let's multiply both sides by 2 again. 6 and 2 times in that modulo. This is 4. And then subtract, wait a minute, 2, yes. Subtract 1 from both sides. Then I have 6 times, oh wait. Yeah, well, it's modulo m1, so there's nothing we can do about it. Again, I get 6 times m1 plus 2 times the modulo of m1 minus 1, which is minus 1 or plus 1. So this is minus 1 to the power. I'm not even sure if there's a solution for that then. Okay, if m1 is 0 and this is 0 is minus 1, so it is to the power m1 plus 1. Or just to the power m1, and then I have to subtract it. Equals 4 times n1 plus 4 is plus 3. But I need to solve for m1. It's not going to help. Too difficult. Nope. Let me try it. I give up. Start at 2. And 1 starts as 1, and 1 starts at 2. And now we do that. Let me just copy this. Type foo, and then I'll have a random new file. But no, it already existed. I don't think this is very interesting. So we have int m1 equals 1, and then for int n1 is starting at 2, 1 less than 100 plus plus n1, and then we do if n1 modulo 3 equals 0, continue, otherwise increment m1, and then now I want to calculate m1. I have a formula that function of, so assert m1 equals some function of n1. Except that the assert will continuously fail. So instead of the assert, I'll actually just print the difference. So minus m1. So if my function just returns 0, then you get to see the negative value of m1. Is that annoying? Can I not better do m1 minus f? Just, you know, so we begin with something positive. It would also be a nice idea to print n1 itself. I guess, because that's our input. And then a projection onto f, but we show the difference. I think it's still better to do it like that, actually. So, minus m1. Yeah, so now we have a negative value, meaning that we are a little bit off. 0 is not enough. We must add something. And I'm pretty sure that we get in the neighborhood by multiplying, by dividing n with 3 and then multiplying it by 2 again. Well, then round off, go to int. Just int divided by 3 and times 2. Right, so that's pretty close. It's alternating. I mean, we can add 1 and then we get even closer, or 2. And then it's alternating 1 off. But it is not clear how to alternate that, because this value makes a jump here. So we kind of iteratively need our cells, as it were. No. Let's first add 1. Again, add 2. How can I detect that I want to subtract 1 every time the input value is one of these things? Well, it's not like it is odd every time. The 3 is added every time. From here to there we have exactly 3 more. So, and there's n1 divided by 3 and then modulo 2. But first I want to do that it is all modulo 2, so it must be odd after I divide it by 3, or am I crazy? So, wait a minute. No, it's simply modulo 3. But this is 0. It's not simply modulo 3. Let's print modulo 3. So in one mod 3 is there we are, and then subtract 1. So subtract 1. Now it is equal to this thing here. So I'll have to subtract that from fn1, I think. So n minus is this. Okay, so subtract minus 1 means add 1, so I can make this plus 3, and then we subtract n1 modulo 3. But that was your initial value. Not correct. What did I do wrong there? One minus 1. That suddenly is 1 minus 1, 1 minus 1. I don't get this, man. Why is it now 1 minus 1, 1 minus 1? Up here it was 1, 0, 1, 0, 1, 0. And then I make a change and I forget exactly what I did. What change did I make here? Why was it 1, 0? What did I do wrong? Blue, this is arch. What am I doing wrong here? Why? Well, okay. I don't know why, but it is suddenly a change. I mean, come on, here, look. 0, 1, 0, 1, 0, 1, 0, 1. I have no idea how that changed. I should look back my own stream at this point, because really, what the hell? Can I do that? Can you look back? I think so. I'm going to look back my own stream. Okay, I'm editing it now, but this was what produced the 0101. See, we go back a little bit. 01, 01, and so on, right? That was after compiling. And then I go a little bit forwards. And then I'm editing it. Haven't edited it yet. Yeah. So this produced 010101. So that is f of n1 minus m1 produced 010101. We just see it on this string, or this formula. Okay, but this, okay, n1, but it doesn't do anything. And then n divided by 3, n times 2, n plus 2, return n. And here it still says f of n minus m1. This doesn't do anything, I just print something. This program is exactly the same. And this program here on the stream produced 010101. Well, I'm going to change it literally exactly back to what I see in the stream. Because yep, I'll write that away as foo old alt.cxx. And now we run it again. What we have is minus 1, 1. If I compile the current foo, that gives, oh, really? Okay, never mind. There is only one solution here. I forgot to compile. You can see that in the history, I guess. Yeah, I did run make, but make doesn't compile foo.cxx. That was the problem. Oh, I'm such an idiot. Okay. MNN, whatever. I don't know. It's called N. No, it's not N1. N0. It doesn't exist. K. Should I have added it or what? Maybe I should try using my brain instead of just trying things. Okay, what I was doing before I became completely idiot was printing n1 percentage 3 equals n1 percentage 3. So we got something to work with. So I must subtract 2 minus that thing. Okay, plus 2, minus 2, so this can drop out, definitely. Against that one, and this becomes a plus. Now I have the formula, right? Unbelievable. Let's call it M1, because I have no idea what the other one is. Or it's still the same. And then that must be from N1 to N1. I just want to reproduce, so I'm gonna say okay, the f of function. Zip. This calculates M1. So now instead of incrementing M1 every time, we just calculate it. M1 function of N1. Yeah, whatever. It has got to work. So now it's better. Now it's correct. This thing ends in 5. If you apply the Collatz step, you get 5. And that one also exists, but in order to end in this one, you have to start with that one. The 2 here is the modulo 3 of this thing, by the way. And the only thing that really interests me now is the last number, I guess. Or wait, actually, I was just going for only large. Yep, so now this number is much, much larger. Let's see if I can reproduce that. As in, you take this number and that should end in 1 in 2 steps. Meaning if I do times 3 plus 1 and then divide all the powers of 2 away, then I should end, just gonna divide a lot of powers of 2. Print. That is this number, right? Yep. So far it was divisible. Let's continue. 1096. How long can we keep on dividing this? That was no longer good. Was this step still good? Nope. Okay, let's do it the slow way. Divided by 2. Oh, divided by 4. That is definitely okay. Divided by 2. No, it's odd. Okay, so this after one step we end up with this. Now it's odd again. So we know the second step. And I'm pretty sure that now we should end up with this number. So I divided by that. That would be... No, that doesn't look good at all. I don't know. Divided by 2. Divided by 2. Wait, this is the second step, so this must be a power of 2 already. Okay, sorry, I was mistaken. It is more like this times 3 plus 1. Is this the same number? Yeah, although it is a power of 2. This is a power of 2. Right. And all that is not even interesting, because it only becomes interesting now I'm going to print it in binary instead of like that. And now we see that it actually exists of a binary repeat of a certain pattern in the front as well as in the back. And the question is what's in the middle and how. I would say that the number of repeats of 111 is pretty clear. It ends here. So we have 1, 2, 3, 4, 5, 6 repeats. Isn't that a bit weird? Because I'm using 20 here. Is the number of repeats equal to that 20 divided by 3? For example, if I make this 60, and well, both 60. I did it again. I didn't make. No, make should work. Why did I lose my binary output? Oh, because this has a modulo is equal to 0, modulo 3. Coincidence. Well, then let's try 61. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 repeats. Yeah, that is divided by 3 then. But which one is it? I'm not even sure. So let's change one of them back to a much lower value. Let's change this one back to 2. Maybe a bit too low. Let's change it back to 10. Nope, that's indeed the one that repeats up front. So I want to keep this at 61. Yeah, it cannot be 0 modulo 3. Then we skip out here. So this modulo is equal, K1 is equal to the modulo of N1, I think. So anyway, this one we set to 10. Yes. Now, how many repeats do I see here? Oh, I'm not really sure. It's either 0, 1, 0, 1, 0. Well, it's the number of ones, of course. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the number of repeats here is equal to the N2. And this is the repeats of these is equal to N1 divided by 3. So to get a good approximation, I'm going to subtract this repeat. Currently printing it like that, but now I'm going to subtract S, which is a function, 1, 2, N2. where S is defined as this, some bit pattern repeated nx times. The bit pattern is 2 times HB bits long. So if HB is 1, then it will be 2 bits long, and 0, 1, 0, 1, 0, 1 is 2 bits long. And the value of the pattern is 1 as well. So we have S1, 1, and then the number of times that it repeats. So yeah, should be 1, 1. And then subtracting that should give us something that ends on a lot of zeros, right? We cannot pass that. Yep, now we have lots of zeros. I'm pretty sure that the pattern of this one is this, and so we have to divide this then by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So K2, shift left 22, but the 22 is actually 2 plus 2 times N2, of course. Because we were repeating 2 bits N2 times. So every time N2 is increased by 1, we add a 0, 1 at the end, and then, yeah. So if we do that, we have something that ends on 0, 0, 1, 1, 1. And the number of times that this repeats is, I already counted it, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that looks like K2 minus the repeat of 6 bits. And the pattern is 7. Repeated N1 divided by 3 times. Yep, and now we get 0. But did I get it right? Because what happens if I change, let's say, this into 62? Yeah, okay, first 62. Totally off. Not even remotely correct. Okay, so that was 61. This formula is good for 61, but 61. But it's not good for 62. So let's figure out 62 now. Comment this out. I think the first part is correct, though. I only changed N1, right? Yeah. So the first part must be correct. Only this can be wrong, actually. Oh, I have to divide it by the power of 2, 3. That's surprising. Well, not really. That is extraordinary strange though. So now n1 is 1 larger. I have to shift 3 bits more to the left, to the right. So plus 3 times n1. But it was correct when n1 is 60. No, when n1 is 61 it was correct. So minus 3 times 61. You're like, what? Where did that come from? Let's see if this looks correct. Oops. Yeah, now it ends on this, and it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 still. 20. So the n1 divided by 3, so it should still, well, yeah, it should still work. Even for 62, it is 62 now, still working. Now it is 0. Okay, so let's try. Well, 63 is a modulo 3 again, so let's go to 4. Dang, now it's negative. Again, 3 bits off, or I shifted too much. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Maybe I shifted too much, you know. Try this again without that. I shifted too much. So it's not really like 3 times n1. N1? What am I doing with n1? Why am I using n1? I know it is a formula of m1. I should use m1. I'm an idiot, as usual. Yeah, I'm using n1 to, but I should use m1. Okay, this is still n2. So then maybe it's, nah. wait, I'm gonna go to. I have to use M1. What is M1? I don't know. So print M1 as well. And 1 is 43. I think I should make it easier on myself and go a little bit smaller. Like a lot smaller. Let's say we just simply start at 4. No, wait, times 3 at least. Let's start at, I don't know, let's start at 5. And then go to, like not too many, maybe 5-ish, or times 3 is, let's say, I am to 16-ish, and then I'm just gonna count the number of repeats. Yeah, let's see. Let's do it carefully. First you print a real number. And then the idea is that this repeat stays the same. All of them, and it must be 0, 1. So that is the thing that we want to cut off, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Repeat of 10. 10 being N2, so that still holds. Okay. And then the number of zeros that we subtract must of course always fit. You see, if I do this one, and I'm removing too many zeros. So the actual number of zeros that we can remove is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Oh, that looks like a safe bet. Simply the pattern that I just subtracted. So I have a pattern of n times 2 bits, and then that became 0, and then we can shift that out because it's all 2s anyway. And then what is left is something that either ends on 0, 0, or it ends on 0, 0, 0, 1, 1. Oh yeah, that depends then. It depends on... Okay, whatever that, I want first want to know the repeat. So the repeat here is 1, and then we get a repeat of 2. And then a repeat of 3 here, and so on. So it is M1 plus, let's see, that is that divided by 2. So we divided by 2, yeah, I have to subtract 1 and divide it by 2, I guess. Yep. The floor of M1 minus 1 divided by 2 is the number of repeats. But the shift alternates too, because I still have to subtract either this or that. And now I move it the other way around, so I move it up. So I shift by 2 or 5 as a function of M1 modulo 2. Also M1 modulo 2. So it is 1, so 2 and 5, so it is, the difference is 3. So I have 3 times modulo 3 times M1 modulo 2. And that must be subtracted, because if the modulo 1 is less, so I have something minus 3. No, yeah, that's simply 5, I guess. 5 minus 3 times the modulo of M1. If this is 1, we get 2, and if this is the modulo is 0, we get 5. And I multiply this by that, but I might as well shift it. I'll keep it in formula. I'm shifting it here. Okay, let's keep it as a shift. I'm not sure that works though. I don't think you can shift like this with an integer. Let's try it. No, no compile error, so it did work. But we removed 1 repeat too less. And here 2 repeats too less. And here also 2, 1, which is, it's a miss basically. Number of repeats are not correct, or I shift wrong, I don't know. Let's have a look at it again. So my guess that the number of repeats were the number of repeats were this. That's what was my guess. So that's not correct. must not, it must be divided by 2. I'm an idiot. Now it's go okay. So it is 1, 2, 3, 4, and so on. So now it's good. Now it's good. So we got the number of beats correct. Yes. Now we got 0, 3, 0, 3, 0, 3, and so on, I guess. So this 0 is the remainder of these two, and the 3 is this remainder. Okay. Yeah, these are also a function of M1. In this case, M1 modulo 2. Isn't it? So, yeah, I cannot make anything else of it at the moment. And let's see where it really comes from. I think I should shift one less. Comes 6 and 0. Where do I get the 0 from? 3 zeros. Yeah, okay. That's basically, I think. Let's shift one less here. I multiplied it by 2 now. So we have to subtract this. Let's shift one more. Then it becomes 6 instead of 3. This is binary, right? So this is 6. I'm pretty sure that that comes from having subtracted 1 from that. So we have 1 and 7, and I think that's actually a power of 2 minus 1. Although it's really this 7 here. But then the other one, the other pattern, it came from power, so I'm not sure what it is going to be next then. Let's say I'm going to subtract let's say we have 7. Subtracting. I'm adding 1 here. And then I have to subtract a power of 2. Nope. I'm still printing a modulo of 2, right? Let's not do this yet. Yeah, clearly I have to subtract 8 times 1 minus, no, not 8, 3 times 1 minus a modulo. Times 3, so it's, well, 3 times modulo. Whatever. Still not right. Oh. You have to add 2 here. Well, it's not a power of 2. It's not a power of 2. It's a power. It has to do with 3 to the power something. How did I go from 9 to 7? Yeah, right. That's what it is, I think. It's let me come help a variable like help a variable h z set 1. No, it's already z set. Let's make a power of 2 equal to I need 6. Where does the 6 come from? I think 3 times or it's just 6 because it's n2. It's this 2 here. 3 times this 2. That's a constant. 6. And then I subtract 1. And then you divide h by 3 to the power 2, which is 9. So let's write this as 2 times 3. The 2 is, and this is then 3 times 3, 3 to the power 2. Yeah, so now we have 2 to the power 6 is 64, minus 1 is 63, divided by 9 is 7. But we only need that every other M1. The other M1 mean then we do, now we have 7, so I can just subtract that from oops, so already loop h subtract 1, we get 6, and then we can subtract that from K2. And this was still correct, right? The way it is now. Then I get 0 for certain values of M1 modulo 2. Yep. So if modulo M1, if M1 modulo 2 equals 0, then we are exactly on the right value now. And this one should not have subtracted 7, It's minus 6 now. We should have subtracted 1. And that 1 came from this one here. So we should have divided by 1, aka 3 to the power 0. No. H is, sorry, I think H must be 1 at this point. We don't want to subtract anything, so H must be 1 here. And that 1 comes from I have to wreck my brain again. That other one that comes from, I think we were 6. It says 1 minus. I had 6 now, which came from 7 minus 1. That's why I subtract 1. And now I want 1 minus 1. And that one is 3 to the power 1 divided by 3. I think so. No, wait, it is not clear at all. Actually, it is not that difficult at all, because I think I have my repeats correct. This line is correct, and this line is correct, and therefore I can simply set the repeat to 0. So if I set n2 to 0, then we have no repeats. And I set m1 to 1, I guess, so that we don't have any repeats here. Which means I have to set n1 to 2. Yeah. No repeats here. Then m1 is 1. And the other one was n2 to 0. Well, if m1 is 1 modulo 2, that is 1. That's annoying. 1 m wait. And yeah, n1 is 1, so I still get 1 repeat here then. Okay, maybe I can deal with that. So you cannot go lower than 1 here. Yeah, cannot go lower than 2 here. I think that that means that M1 is 1. So then we must start at 1 here. Start as low as possible anyway then. Let's just print that output. No repeats whatsoever. Well, no repeats. I mean, we do have repeats, I think, but this is 1101. I think the 01 is that single repeat. That will be this one, right? That, actually. See, now it feels kind of silly to leave the 0 on here. Is that how it is? I think it worked as follows, right? We have like 777, which is modulo 3 equal to 1. So I leave it like that. And then I add 0, 0. And then we subtract 1 from that. And then you get 1, 1, 0, 1, 0. Yeah, yeah. And then divide by 2 ones or something like that. Nah, not sure. No, it's nonsense. Total nonsense. I have no idea. No, I was going to calculate back from the formula I already found, which is up here, this one. So it's kind of unfortunate that n2 equals 1 now. But I don't think it matters, because n2 is only related to the repeat. So you should still be able to figure out what is left over here by reversing the thing. So using this as a README file, we have this is the correct value. And then if I do this, I need 2 different values of M1, because that's what what I'm searching for is something that depends on the modulo of 2 of M1. So I need at least two values of that, which means that I do need to have another N1 as well. I think then the next one hopefully gives us that. Nope, next one doesn't give anything. Because that's a modulo 3, so I have to do 4 at least. So M1 goes from 2 to 3, and then we get both the values. Except that we don't. Well, then apparently this is my my 7. Oh, really? No. It's either 1, 1 with a 0 or 0, 0 with a 0. That's it. So, but I do have a repeat of 3 1s now. And that repeat was this thing with the 7 that repeats. So, where's my 7 here? So that depends on M1, and we increased M1 in order to get the pattern. So it is understandable that we do get that. So I have to subtract that as well. Cannot go around that. Okay, so I subtract this, I guess. Absolutely a horror. Yep, and then we get 0 and 6. But, you know, might as well now remove that 0 as well. Although, I'm not sure. Okay, no, I'm not sure. So let's leave it in. I don't know. So let's work backwards now from these values and then see what they really are mathematically. No, that's not easy, obviously. So we need values of M1 and N2 for both cases. So I'm going to print both. Actually, we need the modulo 2 of M1. I'll have M1 as well. So M1 modulo 2 equals that, and let's print N2. So N2 is 1 in both cases, and the modulo of M1 is what makes a difference between this value of 6 and 0. Yep. So then I guess, I mean, okay, we have N2 is 1. And M1 equals, I'm just using M1 here, in full. I wonder how that is possible. And that already incorporates a repeater. Let's just work with M1 instead of the modulo then. Although, I don't know. Somehow that should service. Okay, let's say m1 equals, well, what have it printed? To 2 and 3. So in the case of 2, we have that we are left over with 6. So our mysterious 6 equals, let's call the mysterious value v. So v is 6. And we have v. And we go backwards. So here we have left v. Then I am adding, oh boy. Yeah. Plus that times 2 to the power That's a modulo. That's not really fair. Yeah, my modulo is hidden in this. Minus 1 to the power m1. Let's start at the top. I just have to write it out completely, I think. Hopefully you'll get something then. So just 2 to the power this. Minus something there's also a minus 6, I see. Minus 6. And this is something 2 to the power 2 times n2. And this something is 3 plus minus 1 to the power n1. Let's try not to make a mistake. 2 to the power of that minus 3 plus minus 1 to the power m1 times 2 to the power 2 times m plus minus 6. Yep. And then all divided by 18. No. Divided by 18. And then we are here, and then I subtract this. Okay, and S is defined as, so this is 1, 1, and 2. One, 1, and 2. So BP is 1, so it's equal to S1. 1, comma, N2. So HB is 1, so this is 2 to the power 2 times n minus 1 divided by the same thing without the n. 2 to the power 2, so it's 4, 4 to the power 4 to the power n minus 1 divided by 4 to the power, no, divided by 3. And this was 4 to the power n minus 1 divided by 3. This I'm still watching here. It's not good. Okay, 2 minus, this was 4 to the power and 2 minus 1 divided by 3. Yes. And then all divided by 2 to the power uh, 2 times and 2. It's a big formula. Divided by 2 to the power 2 times n2 minus 1 for some reason. And then we subtract this. Which is another S. S multiplied with some I should be able to use Wolfram for this. If you can tell it what S is, and you can just copy and paste it. You can tell it what the functions are. Not sure how that works though. Wolfram Alpha. Anyway, minus that S. So first fill it in like it is here. Times 2 to the power 6 minus 3 times da 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 da. Right. I don't like that modulo. Can I not convert that to already somehow to minus 1 to a power? Put this on a new line. Yeah, let's do an intermezzo. This thing here, this factor here, is obviously equal to 2 to the power 6 divided by 2 to the power 3 times m2 modulo 2, and that is equal to so that is equal to 2 to the power 3 . And I form the other side like minus 1 to the power m1 plus 2 equals, well, as m1 is even, that is 2, odd, it is 1. So this is -1 or +1. I should add 1. This is -1 or +1. So adding 1, then we get 0 or 2. And therefore that is the modulo times 2. And at least two minus that, I guess. So if M0 is 1, if M0 is 0, M1 is 0, then this is 1 plus 1 is 2. So this must be 0, and it is because M1 is 0. And if M1 equals 1, then this becomes 0, and this becomes also 0. So I think that's correct. Yep. Looks totally correct to me. It follows that. Oh, that didn't help. I have it in as a power of 2. Dang. But that's no problem. Different intermezzo. 2 to the power m2 modulo m2. Well, that is either 1 or 2, depending on the modulo value. If the modulo is 0, then it is 1. And if the modulo is 1, then it is 2. So it's actually equal to that, right? If the modulo is, if M1 is, let's say, if the modulo is 0, then this is 1. Yep, and if the modulo is 1, then this is 2, and this is also 2. And from this follows that the modulo is equals of that. Rather minus that. Whatever. -1 to the power of that. -1, I subtract 2 from both sides. And then I divide by -2. Then I get that. Dividing by -2 means, well, let's first divide by -1. So that is then, this becomes 1 minus that. And then divide by 2. Okay, so this then is equal to 2 to the power of 6 divided by 2 to the power, that was 1 plus modulo 2. So what's this? To the power L1 modulo 2. Yeah, to the power 3. This modulo 2, that was this. Okay, well this is divided by 2, I might as well not divide by it. As in, this becomes 2 to the power 7. And there is 2. Well, what do you think? Did I do this correct so far? Because one little mistake. Yeah, I guess the easiest way is to write a little program and just brute force the values here. Well, no, there's not much to calculate, it's just modulos. So only 2 values. Can BC not do this? Let's see. There was this, right? And you want to compare that with this? No. With this. That must be an easier way. Totally wrong. Okay. Well, in the end, I must get something like this anyway. So although this is something multiplied with something n2, there's no n2 here. God, why is this so difficult? It's good. Yeah, it feels like a bit of a dead end, actually. I don't think there's a sensible way to find those that 0 and that 7 at the moment. Not in this way anyway. Yep, not doing that. Also not totally convinced that a repeat makes much sense, but well, in the meantime, I guess I can just do can just hard code it, as it were, instead of guessing what it is. So I want to do here k2 minus is something. The something being ding 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 error. Something being that I need my repeat back. So otherwise I don't know. Or do I? No, I don't. Wait a minute. Actually, I do. I do know. I think I do. Yes, I should know. It is, yeah, okay. So this is 6. 6. I'll just make it 6 minus 6 times this, I guess. Or I'll make it 3 anyway. I really don't care anymore now about that either. So remove the -1 here. And then we make this a 5 again. And then I think I have, okay, and then I'll just subtract here. 3 minus 3 times modulo. And then should be able to, oh wait, what? Never mind, I think I should subtract it there. Yeah, let's increase these loops a little bit again. 5. Oh, that seems to work perfectly. Which means that now I can do K2, shift left, this. Well, that seems that, why not, no, that doesn't make much sense, does it? Suspiciously looks alike, right? First subtract something and then divide it by 2 to the power, and that's the same thing. That feels like something, but what? No, I don't know. I don't care. Let's keep it like this. Should be able to simplify this. Okay, let's make a second variable known. So ZZ KS, which means that we're using S. And then I do shift KS, then more KS and more. Oh wait, the other way around. No, not the other way around. Wait. What am I doing? I want to go the other way around. So yeah, I had minus. Huh? Set K to S. Go the other way around. So I do start with this S. And then I shifted that up. Now we add this, and then shift it even more up by that. And now we add this or something. Poor man's git. Navigate to S, and I want to print K2 minus K2S, and that should be 0 at all times. I'm not really interested anymore in this, I must say, just that. That's a lot of zeros. Well, a lot, let's make it a lot. Yeah, only large is exactly not what I'm doing. I was using the 10 here, as if that's large. Put this one back as well, a 10. $120, really? That's a bit too much. Let's make that 30, I don't know. And 30. Set these two to 0. Well, that's a lot of zeros all over the place. So I guess I expressed it more or less, at least now, in terms of S. With some mysterious, nobody knows what it is in between. But the S's are at least there. I have to guess. We'll have to guess what this means. Yeah, the 2 times n2 is exactly what we append here. So this is more like append, 0, 1 repeated. And this is then begin with that repeated. Yeah. So since that works, you can delete this. Yeah, either is good. Let's I don't know. Let's just use this one still. Now I want to go and add a loop and then, well, figure out the formula for K3, as it were. So let's go to let's make them large again. Now I do think I need 2 different values for M1. And now we're going to have an M2 is 2, I think. So this is an, let's say, large-ish, 10, maybe 15, I don't know. Well, 15, let's say 16 and 17 or something like that. That should give me 2 different values of M1. And here we have we should have an M2 as well, which I don't know really yet what that's going to be. At least it's starting at M1 percentage 2. So the increment is very unclear. Although we'll have to skip. No, the starting point. Yeah, difficult. And difficult. Nobody knows what it has to be. That is a mystery yet. Therefore, we cannot work with large N2 yet, I think. Let's set that to 0 and then just start at M1 modulo 2. So we have the full loop and defining in N1, sorry, in M2 here, which is set to, I don't know. The other one was also like kind of what the hell is it? Value, I don't know. Let's just set it to something, or maybe I set the other one to 1 because I started at 2. Could that be it? Oh yeah, right. Why not start at 0? Let's start at, no. Let's start at the first value here. It kind of depends on M1. If this is, I think, yeah, well, anyway. Calculate, let's do the same thing as here. I'm calculating it and printing it. So I'm skipping the increment of M2 and K2 modulo 3 equals 0. Oh yeah, right. I remember. M2 must be equal to the modulo of modulo 3 of K2. Is that correct? I wish I had not deleted old code. At some point this started to work and then I just deleted stuff because I got my values. Or maybe I'm doing it here. Yeah, doing it here. Where am I multiplying with the modulo 3? Only here in a comment. Yeah, now I remember. M1 is the index of this set. Now we begin at 1. For the first element, for N1 is 2. In which case K equals 5. So that's 10. Okay, if it's simply the index and I start at 1, and which is an actual number, so I just start at 1 for some reason instead of at 0. Nobody knows on why. Why? Unbelievable. No, I remember to have used M1 with the index K1. Sorry, M1. So it was the index of this thing, and that starts at 0. It's the first value that I push back here is, there's the multiplication. K1 modulo 3 multiplied with K1. Pretty sure the first pushback is for 10, so that is for K1 M3 is 2. Oh, of course, yeah. That's, I started 1, but I immediately increment before we do anything. So actually we start at 2. I guess then it is. Well, I guess we start at a modulo of the K value. Sorry, the K value modulo 3. For whatever reason. And therefore, in order to find out what M2 then should be, I'll have to calculate K2 and then a modulo 3 of that. And that would then be the starting value. So here I'm going to do less than or equal M1 modulo 2. So we have only a single loop. And I'm going to print K2 as well as K2 modulo 3. And that then should be my beginning M2 value, I think. Beginning after the increment inside this function. So it's kind of like at this point here. Let's print it here instead of here. And it is then the M2 function. So the M2 function should be equal to that for the given K2. For the given K2. No, we give an n to. Nope. Yeah, Omi Hossein ask why people often use plus plus I. It's because if it is a custom class for an iterator, like from the standard library, iterator over some STL container, then I++ must make a copy internally. So it's slower. It does not affect either compile time or compile speed when it is a built-in. So for an integer you can use I++. But since I use iterators a lot, and it does make a difference in that case. I mean, I++ would have to increment it and then return the old value. So you have to start with making a copy, then increment it internally, and then return the copy. So it's just slower. So for iterators, I always use plus plus I, and then I'm so used to it, I also use that in every loop, also for built-in variables. I mean, why make an exception then? Why do I get this kind of large output here? I don't get it. So I think nothing is printed for some reason. Oh, it's 1. You can see it here. It prints 1 and then followed by a binary value. So sneaky. Okay, still hard to wrap my head around it. So here the modulo 3 of K2 is 0, therefore we don't have an M2. But therefore I continue. And there is a new line here, and there is no new line. I mean, it's confusing that the K2 is here, right? But okay, there's somehow, I think the new line is printed after the binary output, but the binary output doesn't exist. You just get a new line. And now we get the next loop value for, I should put a new line after K1 maybe, and then have an indentation. I think the whole printing went a bit wrong here. Let's fix the printing, it is unreadable. So after K1, I want to print K1 here and then do yeah, we'll have the new line here. So I'm printing M1 here for some reason. Let's just do a new line here. And then all output of, oh, we start here, so I have an indentation here then, I guess. This is inside the loop. Yeah, I'm not printing new lines here, do I? Am I? I'm here. Do I want it? No, I don't want it. Not for the inner loop anyway. Which in a second is going to be the outer loop, yeah. So let's comment it out for now. And then I need an indentation in front of it. And then print stuff, and then we print a new line within the loop. No, at the end of the loop. And then they put 2 spaces after it. I don't know, man. It's a mess. See, now my K1 is indented. Well, here it is not. Maybe I should indent this one too. The first K1, indent the first K1 and indent the K2 further. Does that make any sense? Probably. No. Why? Wait, this is just in front of the next K1, so definitely no. Just one indentation would do there, and then I don't have indentations for K2. I just have, well, I have no new lines. I mean, so yeah. Okay, it seems that the K2 is being printed twice now. That's also confusing. Binary 2 and printed as binary at the end. Here I'm printing it again while it was already printed. I mean, either I skip it like this. I don't know what happens then, but yeah, just semicolon. So now we have 2 semicolons. No, don't want that either. I think I just should put all the K2s on a new line as well, really. We're going to get K3s as well. Cannot print cubes anyway. So an indentation will do fine. Yeah, that means that I can delete the indentation here. And then add the indentation in front of here. And then delete the indentation here. And then delete the indentation here. And add it here. And then after printing everything within this loop, we need a new line. Is this going to work? I think so. That looks better, right? And I need to get my print new line back here to continue. Okay, and then we have a semicolon too much. Somewhere between. Yeah, there's no, absolutely no need to print a semicolon here. Okay, how is it possible that here we have a 2 and here a 1 and a 0 and a 1? So that's whatever I'm passing to M to F. Which is N2, and N2 is this loop here. Which begins at either M1 is 0, 1, isn't it? No, M1 increments. Want M1 modulo 2 is 0, 1, obviously, yeah. So, N2 begins at 0 or 1, and then runs to 1 or 2. Okay, so we get all the values. And I want M2 at the start value to be equal to the modulo 3 of K2, which I'm printing. Yeah, that's correct. Is this correct? Let's print in M2 too, because I do calculate it currently. Well, I'm not too sure about the starting value here. Yeah, that was the problem. Right, so what we really mean is that I print M2 as well, and then the difference is what is the starting value. The starting value is now 0, so yeah, this value minus M2 is actually the starting value. So I could do start value equals this value minus current value of M2. Well, that's promising. It says 0. I guess it's 0. Okay. Not that I understand it, but quickly continue. The starting value is 0 for some mysterious reason. Nobody gets it. Really, absolutely have no clue why it's 0. But let's quickly continue. So now I can print the M2 value as a function of N2, I mean. Because you have to recreate that function. And then let's make a few values of that. Let's do a little bit more than this, like 20 maybe, and then... Oh wait, I'm not using that. What? Am I? No, I'm not. I am. Wait. So in one, I now have 2 values, so let's make that a little bit more, like what I said, 3 more. It's definitely enough. And then here I'm going to do a load of values. Wait, well, I'm doing this, and we're going to do all the way up to 30. And now you see that indeed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, of course, it's just incremented. And the input is 1, 2, 3 is skipped. 0 is also skipped for that matter. So it's probably the same as M1F, but I'm not sure. So that's why I wanted to test this. As I would say, let's just print M1F as well. Maybe it is already correct. So M1F of N2 is equal to M1F of Yeah. And that's exactly the same value. Yeah. So no change there. Very encouraging. But I put it in a name, and if only if it is the next one is also the same, then I'll rename it. But for now, I'll just name it like that. I just copy it. It's the same, but okay, so now I can replace M2 the way we did here. That is, this can go, and I copy this, and then we put that here instead, and now I have M2 as function of N2 as a formula, so I can skip. No longer have to begin at the beginning. Okay, now I'll have to make a new loop. Let's do the same thing here. Print value of M2. And then we make a new loop. Where does that start? I don't know yet. Just start at 1 for now. And 3 less than or equal 10 plus plus in 3. Well, there was a second way to calculate it. So depends on M1. It's up there. So this, we don't do that at the moment, or I shouldn't, or I don't want to, or I don't have to, or it's printing K2 anyway. It's gonna belongs here, maybe, and I already have that, so goodbye. Then we have skip, print M2, and what is this? I don't know. Right. Then inside loop, I have to calculate, yeah, K3, and we don't know the formula yet. That's fun. Isn't that fun? So I have actually only M2. Sorry, yeah, M2 is defined as K2 times K2 modulo 3 with K2 element of K2. remove all the zeros. I don't know if that's correct, but it's just it's just a trick to write it in pseudo mathematics, I guess. I'm not sure if this is correct. I mean, this means remove the set, so yeah. But the trick is that I multiply with the modulo of 3, and if this is 0, then the result is of course 0. And all of those I remove again. So the only thing that is left in M2 are the values of are the values K2 that are not equal to 0 modulo 3. Plus I multiply them by 2 if the modulo equals to 2. The result is then that all the elements of M2 are equal to 1 modulo 3. So, can we do that? I think we can. So we begin with an M value. Now I already used there a lowercase m2. So I have now zz. I'm gonna call it m2. I don't know. The capitals stands for set. In this case, it's not. But what do I use them to? What am I to do? Let's see. So if modulo of K2 percentage 3 equals 0, we already skipped this loop. So inside here, this is never 0 and we never have to remove it. I can simply take K2 and multiply it with the modulo of K2. And then we run over all the elements. I don't want to call it capital. Let's call it K for now. Kind of nonsense, but I don't know. Anyway, K2 times K2 mod 3. So the modulo 3 of these values are all equal to 1. So if now I do K minus is 1. Hey, Post Bunny, yeah, I know. It's a trap. So now the modulo 3 equals 0, so therefore we can safely divide it by 3. And well, I'm just calculating K3 here, I guess, slowly but truly. Let's see. Yeah, and we can multiply K3 with a random power of 2. So I shifted, sorry, power of 4. So I shifted 2 times N3, which I think means that it should start at 0. So we take values from K2, multiply them by, to skip everything that is modulo, that is 0 modulo 3, multiply the modulo, the values of 2 modulo 3 with 2, so that the modulo 3 becomes 1, Then we multiply it by a random power of 4. Subtract 1 and divide by 3. That means that whatever value we have now is 1 odd. It must be odd because it was odd after this. How do I explain that? I'm not sure if it's odd now, suddenly. What? Help! I guess we'll see. Let's print it. As binary as well. I'm going to print K3 as binary. We need a separator here. What did we do in the other case? I need an indentation as well. I guess if this is my calculation, I need something like this. But then for K3 with 2 extra spaces indentation. I need a new line as well somewhere. I guess like that. I don't know, I'll clean it up when I see it. Well, it's not always odd, apparently. It's a 0 here. That's odd. This makes no sense whatsoever. Okay, 3 is getting smaller and smaller and smaller. What? Why? How? Yeah, plus all the even values is nonsense. They're nonsense. It's even possible that I get them. Oh, I know. The reason I get them is because I must multiply by at least a factor of 2. So again, if m2 modulo 2 is 0, no, sorry, well, I multiplied with this, okay, 2 modulo 3. And alternating, I'm multiplying with 1, 2, 1, 2, 1, 2. And also alternating, I'm incrementing m2. And therefore, m2 modulo 2 gives me an indication of whether or not I multiplied with 1 or 2. And therefore, this also must start with m2 percentage 2. Because now we always have multiplied by 2, either intrinsically because we did it here, so K2 is already even, either K2 is even, K2 is even, or N3 starts at 1, which means already multiply by 2 here. So K3 is even after this. Then we subtract 1. That makes it uneven. Then they divide it by an uneven number. And then I would like to claim that it therefore is still uneven afterwards. But it's of course not true. Really? And still magically it should work. Shouldn't it? Shouldn't it? I'm gonna try it. Magically does not work. Nope. Repeated zeros all the time. Why? Okay, let's go drastically smaller here because the numbers are way too large now. Let's see what's going on if it is started to. Let's do 2, 3, 4, 5 ish. And here I go, let's say, I think that the effect of starting like this, well, of course, I'm not sure, but because the M1F is equal to M2F, and that also worked for N2. I mean, it worked here, so it should work for this one as well. But I can add an assert, I guess, to check it. So either M2 percentage 2, which gives us an extra factor of 4 here even, is larger than 0, or K2 must be even. I'm highlighting this one, what I meant this one. Yeah, so that K3 is always even. So yes, K3 is always even before we do this one, at least for the initial value. That was the reason that we start like that. And the assertion fails. Not to mention that I'm printing a lot of -1s here. What the hell's going on? Nope, that's not what I meant. It is this. Do I see that wrong? Yeah, K3. Yeah, I multiply. Really? I multiply by K2 modulo 3, which is either 1 or 2. So K3 becomes even if this is even. Yeah. That's correct-ish, more correct-ish. So basically means that this is equal to 2 then. Still not true. Plus a lot of shit. Okay, I'm gonna turn it around. I still need a formula for that. But for now I can just set the starting value to whatever I just asserted, basically. That is, you can start at 0 if this is true. Otherwise you have to start at 1. And then at the very least at this point K3 mod 2 must be equal to 0. I really want that to be true always anyway. Not just for the initial value. Well, that's going to happen, of course, because we just increment n3. So after that, this is always even. And I meant K3. Okay, explain that. I'm shifting it the wrong way. Oh my God. Okay. Yeah. Right. That's why the number K3 became smaller. It's like, what is this? It becomes smaller. Oh boy. Okay. Now it becomes larger, and my cert doesn't fire. So yay. Okay, we believe that. So now I have K3. Now let's start with checking if these numbers are correct. So I'm going to print them as decimal. And then we have to extract them. So grab K3 equals something, and then run it through the serial editor. Just remove everything from the start, I guess, just everything. Nah, okay, from the start. Everything from the start up till and including K3 equals. All the numbers, and then I'm going to sort them numerically. And then I want to compare them with the output of. I wrote a little program somewhere that. Isn't that foo? Maybe put it in K2. No. Oh, no. Or test 2. Test 2. Yep. So make this 3. It does what I expect the way it is now. So I run this. It prints. This should be K2 values, right? Yep. So the number of steps equal to 3, then it is a K3 value. So these are my K3 values. 1735, really? 1735, 69, 75. 1735, 69, 75. Well, I guess it's correct, but let's compare all of it. So this is troop 1, and this is troop 2. Diff minus U, troop 1 and troop 2. It's not good. We're missing stuff, and then one of them is much larger. Well, that's probably mine. So the math output, this is the diff from, there's a missing, remove, so if troop 2 is less, troop 2 is my math, so we're missing values. Interesting, right? The first value that we are missing is like all the way up here. 1137. This is the first value that we are missing. The rest is generated. And then it just skips it and go to 1205. What? Why am I not generating 1137? the feeling that it has to do with the nope. Even 2 in a row. Anyway, I think it has to do with the starting value of that I just worked on. Not that one, and I wanted math there. So let's just start at 0, regardless. Let's see what that gives. Now we generate even numbers. And this is still missing. Oh, that's super interesting. Wow, why are these still missing? Unbelievable. What? How is this possible? Why? Okay, let's call this like that. Editing math again and putting this back. Yeah, it just generates stupid stuff, and all of them are even, so I guess the starting value was correct. Okay, well, interesting. 1137 is missing. Well, first I want to be 100% sure that it is a K3 value. So 1137 is odd. 3 plus 1 divided by 2 divided by 2 is odd. So this was one step. Second step, times 3 plus 1. Yeah, already see it coming. Divided by 512. That was 2 steps, and then this is K1 value. So that's indeed 3 steps. The value is correct. And why is 1137 not generated? Well. Moreover, we know that it should be generated from that value, right? I mean, 11 equals this value times 2 times 2 is times 4. Now we have this minus 1 divided by 3. Yep. So let's copy this, go to the code. why are we never printing that value? Maybe we never have 853 as a starting point. Maybe 853 is not even part of K2. Would that be possible? I think I print K2 as well. I mean, if K2 is that, and then okay, what is the modulo 3 of that thing? Please let it be 1. Thank God. Oops, quit. So the modulo 3 of this thing is 1, therefore it should be literally element of M2. This is 1. It is element or should be element of K2. Therefore it should be element of M2. Therefore it should be at some point in here. And then we shift left by is N3 is equals 1. Well, it either starts at 0 or 1, so it's definitely going to be 1. So we shift it 2. That is multiplying by 4, and then we subtract 1 and divide by 3, and we should get 1137. So I don't think that the reason that we don't print 1137 is because K2 is never equal to 853. Insert K2 is unequal 853. And that's the reason, I think. Yep, that doesn't assert. Well, then we can repeat the same question. Why is it never element of K2? Because 853. Let's go to BC. 853 is odd, so we multiply it by 3 and add 1. And then we get definitely a power of 2 times 5. That is a power of 2 times. Yes, yes. I knew it. No, I didn't know it, but now I realize it. Oh, yeah. Well, funny. Really funny. Okay, who else knows what it is? That power of 2 is so high, I simply didn't do it. We only go up 3. Ridiculously small. So I'm not really missing anything. It's just skipping the things where the values are not large enough. So everything works. Everything works. Great. That was not a problem. The values are correct, and let's print this binary again. That's an interesting binary number. It's a new version of binary coming soon. Okay, there we are. Well, this is going to be simple, I suppose. I don't think it repeats enough. Okay, the only thing is continue with this. This is totally not repeating enough. We need to see the repeats. So the small values was only necessary to do a quick check. But now we're going to, I guess, large. I do this one, we just run till 30, and there we run till, I don't know why I edited that. Well, I know, but let's just go to 30. In the same way even. It's a bit weird that this whole define, I keep editing it anyway, but at least I can leave my starting value alone now. I suppose. So, well, now we have a lot of values, and this loop runs all the way till 10. This is not very important. Let me reduce that a little bit. 5. Okay, well, now we see repeats, I guess. So here we have 5 times a repeat of 0, 1, and then we have a lot of repeats of what you already saw in the last one. And then there might be some craft here, and then we have another repeat here. And the question is, when does this repeat start? Well, I bet it's 6 times 3 is 18 bits, but you don't know how many zeros are in front of it, so you still have to find it, or calculate it, of course. Of course you can calculate it. In fact, I already found the series of it. On the online encyclopedia of integers. Probably odd. So my guess is that that's the number, because it repeats again here, right? Yes. How many are these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Who would have known? So, oops. Yeah, well, this bot. GDB. Sitting in the dark. Bunny, lights on. Oh, doesn't work. Alexa. No, I don't have that. Very idea. Maybe I should, because I'm too lazy to turn on. Yeah, I remember that number. I think it's even enough to find it back. Isn't it like yeah, I cannot remember. Whoa. Yeah, well, sad. Nevertheless, what am I doing here? I wanted to go to without the F there. And then we print 1, 7. No, that's the age of someone. Stop this number. 1, 7, bang! Search. Is that it? I think so. But how are we sure? How can we be sure that this is it? Yeah, I remember this number. You've seen this before, right? Previous stream, don't believe it? Actually, wrote a program even that printed it, I think. Definitely the number. Okay, so we can calculate that. But for now, I'll just hard code it. So we have this pattern repeated a few times. And the question is, how often? Well, if this is N3, then this must be N1. So let's increase N1 a lot. And I mean a lot, because you have to kind of feel for how often it repeats. I have the feeling that it is something like this divided by 9. So let's go for 90, 180, 200. No, I have some counting to do. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22. Okay, 200 divided by 22. Is 9. Who would have thought that? Well, almost 9. Let me turn on the lights. It is a rock. And I should go eat. Maybe we should quit now. This is a live stream of me doing the dishes. But I didn't even eat breakfast. I'm an idiot. No breakfast, no lunch. Should be something. But first, I left my glasses in the kitchen. Okay. I'm back. Divided by 9. So, well, that's one thing. But I also need to know the offset. I mean, if you look at these, no, I deleted it. Such an idiot. To do it the hard way. It is most definitely going to be K3 minus S something, where S is a repeat of 18 bits, pattern 9703, what was it? God. And I type it to 3. No, 9709. That's a pattern, right? And then I think I have to put patterns between the ZZ as if they are going to be longer than yeah, well, eventually maybe. And how often I repeat them, N1 divided by 9, but I'm not sure, of course. And then I have to shift this as well a lot. What is the easiest way to find that? I could divide it through this. Yeah, yes, Boys Bunny, you are correct. That's why I recognize it too. But I couldn't remember it before I saw it again. Oh, you did. Okay. Yeah, if I have a number that ends on a repeat of this number, and I divide it by that, then we get a one with 17 zeros, and then a 1 and again 17 zeros, etc. Yes, so, or a division by 0, of course. That's also possible. Do not divide by 0. It's not 0. Well, that's surprising. Well, it would be 0 if n1 is not divisible by... Yeah, n1 is too small. And if n1 is too small, this wouldn't work. Cannot divide by it. I want a large n1s. Like from the start. As in, why would I do anything else than 200? Large. Well, 200 was a bit very large, maybe. Although, let's leave big. Large, I mean. Deep. Ping. Well, it looks like a one with a lot of zeros, but it's not what I had in mind. What happened here? Big numbers, that's for sure. Why? Why do I get this? I'm sorry, but I'll have to go back to not dividing by this number. See what we had. Maybe print the number itself. Well, let's print like... I forgot to print K3 as well. Why? K3 is... That's still... Yeah. Now, okay, it should be dividing by this number. Oh, I'm already repeating it. Yeah, of course, then you get 1. Followed by a lot of zeros. Yes. But it's maybe not safe. So let's just divide by... That's what I really want to do, I think. Initially. Divided by... yeah, I don't know. Maybe it's... I don't know. It feels like maybe not, you know, safe-ish. Dividing by a large number. On the other hand... Getting a 1 with a lot of zeros is at least encouraging. I'm just going to divide by this binary number and then we get what I wanted. A 1 with 17 zeros. A lot of times, and then what we wanted to do is find the last one such thing, so that would be here. And then, I mean, like, really... all the way up till there, and then I need to know how many bits are in the remaining part. So, but I don't want to count them manually, and I want to print them every time. How shall we do that? How can I get... strange. There's a one with a lot of zeros. And then it starts to make sense as in, you know, there is only something small. 0, 3, 7, 3 times 7. No, that would be 21. This is actually, I don't know what it is. Anyway. Okay, I'll just have to count it. That's nonsense, but I still do. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, now, anyway, I see a pattern here, 3 bits, and then followed by 0, and then followed by a growing number of ones. And then here it's something else. And then we get something else again and again. And then at some point you get something else again. Yeah, okay. What that has to do with. I understand what I'm doing wrong. I thought, well, hey, let's get rid of the larger part, you know, everything that's red here. But that's what I would like. But life is not like that. You have to start from the other side. Let's start from the other side. So yeah, I defined large n2, which is stupid. And we don't need this anymore because we're going to work from the other side. So that would do 50 is enough. And then we turn off. Oh no, I didn't define it. I'll do $replace 0, compile. Okay, I'm not getting something. Why is this not ending on a lot of 0, 1, 0, 1, 0, 1s? Did I already do something to my K3? Yes, I divided it by something. I'm an idiot. Let's not divide by this just yet. Now it ends on 0, 1, 0, 1, 0, 1. And the question is, well, 1, how many? And I would think that, well, we get 1 extra every time. And we begin with 0. This is no 0, 1 here, that's for sure. So then the question is, what are we enumerating over here? Well, clearly n3. So I see a pattern. I see a pattern in the code, as it were. Seven. Yes, this one. N2. This one, even both of them, both of these two, occur here as well. But then the other way around. So we first subtract them, and then I'll shift it. But let's first subtract it. And this is then n3. Life is simple, and that's going to go to be true for any k, all the way up till infinity. Okay, this is k3. Yes, so now it ends on zeros. And this is null zeros, and here of course 2, so I don't know what the value is of K3, unfortunately. But here the first one has 4. And here the first one has 0, and here the first one has 4, and here the first one has 0. And now we add 2 every time, and here we add also 2 every time. So it's like either starting at 0 or at 4, depending on, well, I guess a modulo of something. That would be the modulo 2 of M3. I really wish I did not. Wait a minute, I might have that one as well, or not. No, I don't see it. This should be possible anyway. Maybe so yeah, at least nothing, and then 4 zeros, and then 8 zeros. Okay, that's not what I expected. And this one starts as 1, 2, 6. What? I'm shifting them the wrong way again. Starts to be a habit. Okay, yeah, all the zeros are gone, and here we have something that ends on 2 zeros. But remember, the last time we had 7 and 0, and there were 2 zeros and 3 ones. So maybe these 2 zeros are the same as the previous 2 zeros. And then, yeah. I mean, I had the feeling then back then already to leave 1 0 on it and then see it as, you know, something, well, 1 was borrowed, which is exactly the case, by the way. So if you append the 1, then you already see the pattern jump out. It's simply the 0, 0, 1, 3 zeros and 3 ones repeated, except that this one got it's 1 borrowed. But that's where this pattern comes from. And in this case we have, yeah, that is less clear, I would say. But I'm not here to understand that yet. I just want to see the patterns and write some formula and then see the pattern in the formulas. Although, you know, it doesn't hurt to understand that this is actually just 7 minus 1 divided by 2. Well, this one is harder to understand unless you would again see it as a 0, 0. All of them are the same. So yeah, that means that I'm going to treat this as the 3 and that as a 0, and then we have to remove respectively 2 and 5. And we know that pattern in the code. That is something I saw, yeah. So depending on the modulo, it's either sorry, this one. Depending on the modulo, it's either 3 or 0. So 2 bits or no bits at all. And then it's the same 7. It has to be, yeah. And then this is the shift. So really, these two lines are also appearing again. Copy everything. You can copy everything. Okay, let's start with the opposite of, yeah, why not both? Why? Copy it. Copy, and then we're going to append that here, reverse them, really reverse them, as in minus, shift the other way, and then increment this, M2, and then hope that it works, ish. Actually K3S, because I'm basing it on S now. That's why I converted the other one to S as well. So now here either we subtract 0, namely if M2 modulo 2 is 1, then we subtract nothing. And otherwise we subtract 6. Oh, wait. I want to subtract 3. No, subtract 3, yeah. If modulo is 0 here, then we subtract 3. And if we subtract 3, then the amount that we wanted to shift was larger. So from 2 bits to 5 bits, no, that's 3 more. So if we subtract 3, then this is 0, and then we shift 5 bits, and otherwise if we subtract 0, then we move 2 bits. So yes, this is it. This is most definitely the code. Excuse me. But now I have everywhere an annoying leading 3 zeros. Well, I'm pretty sure that the actual pattern is this. 3 zeros on the other side. Is it always 3 zeros? Like completely independent of anything else? I mean, at some point it's so small that there wouldn't be room anymore for 3 zeros. Yeah, there's no 3 zeros here. But there are 3 zeros here. Why are there no 3 zeros here? I would say because that is the pattern. The 3 ones disappear at the same time. So it is 1 1 1 1 1 0 0 0. That is repeating. Really? Yeah, looks like it. 0 times, 1 time, 2 times, 3 times. Let's highlight it. 4 times, 5, 6, 7, I guess, 8, 9, and so on and so on. Okay, well, I don't know, but that seems to be it. Oh, but here we end on 333. Oh, that's suspicious. Maybe, well, that's weird. I like this one much better. Ending on my 3 ones. Maybe I shifted the 3 ones here out accidentally or something. Yeah, this is no good. But yeah, if I shifted the 3 ones out, then at the very least it should end on 3 zeros. At the moment that there is nothing. So you like 2 zeros, 2 zeros left. Yeah. And now I suddenly we switch here. Holy what? Oh, this is 0. Sorry. No repeat. Okay, let me scroll back again to down until we get. Huh? I would have sworn that it ended on. Oh no, that's yeah. It ends on 3 zeros. Yeah. And then sometime at some point it doesn't anymore. I mean, yeah, here. That's what I mean. Really interesting. I think it has to do with I think I might understand it actually. Yeah. I think this must have come from 3 zeros, 3 ones, but we had to divide by 3. What happens to such a pattern if you divide by 3? I mean, we had to divide by 3 because of what is above here. And I wouldn't be surprised if this bit pattern changes. But no, I mean, or yes, I don't know. Does it? I mean, it would be lovely, wouldn't it? Print. I cannot print binary. I need an online binary editor. I found one a while ago. Online binary calculator. I think I had this one. It worked pretty well. But I need a lot of zeros and ones. Can it do this? So let's try 1 1 1 0 0 0 1 1 1 0 0 0. Divided by 3. Calculate. Nah, become something different. Okay, then what do you need to get? Oh, this is a power of 2, of course. I'm an idiot, as usual. Yeah. The killing math pearl instead of the killing joke. Well, no, yeah, you're right. I should eat, but it is 5 p.m., so I still have half an hour at least to be normal, and then I'm defrosting chicken. So that's what I'm waiting for. But okay, I'll 5:30, so in 23 minutes I'll definitely have to stop the stream and I'll go eat. No matter what I'm doing. In the middle. I really wish I understood why these bits swap. Because it's a bit random to remove them the way they are now. At least. Now look at that. This bloody pattern that repeats all the way from here till there has 4 ones in it. So these 3 ones are actually part of this pattern, and then maybe one was bordered. Is that possible? Not sure. But it looks very suspicious, I mean. Very suspicious. I had not expected that I would not be able to see the repeats. I mean, I know how often it repeats, right? At least I thought so. But then suddenly, out of nowhere, they swap bits. The zeros and ones are swapped. Like, what the hell? Okay, let me. Yeah, but that is it. I see. You know, like this one is 1, 2, 3, 4, 5 times repeat, and it ends on 3 zeros. And this one has 4 repeats. I mean, above this repeat, and it ends not on zeros. So what happens when you get a 3? 3 times repeat. Still not ending on zeros. Okay, what's going on now? Now it's ending on as it's ending on 0001, so not on zeros. And then here, okay, still just hard to see, but 111 at the end. Here 2, here 2, here 2, here 2, here 2. And it keeps ending on O, and then it switches to something else. Oh, well, that's just 0 times. Sorry, you can skip that. And this, oh, what? This ends on zeros again. Whoa, okay. While still having a 4-time repeat. Dang. Well, maybe not. Maybe not. Let's take the full repeat. Well, this is the actual repeat. Plus 4 zeros in front of it. So we do go here from 1, 2, 3, 4, 5 to 4. And exactly at that moment, we go from ending on 3 zeros to ending on 3 ones. So maybe it should look at this pattern. Let's see if it switches again when we do go to 3. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, blah, 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 still 4. Boringly long 4. There's 3. So here we end on 3 ones with 4 repeats. And here we end on 3 zeros with 3 repeats. Yes. But it's not clear if the pattern is inverted, which is extremely unlikely. I think it's just a power of 2. So there is a power of 8 for some reason, 2 to the power 3. That we have to remove, I think, whenever this repeat is odd, modulo 2. I mean, this goes on, right? So as soon as you see 2 repeats, it must be ending on zeros again. There we are. Yep, all zeros, here all ones. So what I'm going to do is to take the number of repeats here, which I think I already had, modulo 2, and then if that is 0, you want to shift 3. So basically shift 3 minus 3 times the modulo of that of the repeat. And the repeat was this, n divided by 9. And 1 divided by 9. And well, the floor of that, I guess we get a floor automatically, but well, let's help it a little bit. To be clear. Oh, wait. The modulo of this. This is the repeat, and then the modulo 2 of that. And then times 3, and then negative, and whatever, the rest. Okay, and now I remember that there was something divided by 9. Is M3 not exactly what we need here? That would be nice. It was simply M3 modulo 2. Just like here. but then for a shift. I don't know. Is it really n1? I guess it is n1, right? n1 divided by 9. I don't want to. That's the thing. Yeah, I do not want to use n1. Why am I using n1 here? I should using m1. How can we convert m1 back to n1 divided by 9? We'll never know. I'm too stupid for that. So instead, we'll just print it. We have m1 and we want n1 divided by 9 modulo 2. Well, actually I want it here as well, so I really know I just want n1 divided by 9. For the repeat and so on. Very important. Flushing. It's just imagine we crash just before it prints one of these very important values. Double trouble. Invalid operands of type blah 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 blah. Double and int. Oh, the stupid floor returns. Floor out of the door. Just int. I mean, it's already an int, but you never know. I mean, no. I suppose you just don't have to do this. And 1 divided by 9 is an int, so it's not going to. The compiler should not and cannot and must not think, hey, let's optimize that 3 times. Let's just divide by 3. Not gonna happen. Okay, grab n1 equals okay. Let's instead grab for stars, and then let's sort it and make it unique. No. What? NU? And suddenly nothing, we don't need it anymore? Dude. And still nothing. Nope. Exactly not what I wanted. How can sort minus n, which you then do a numeric sort, suddenly sort on the first one here, and then the 2, and then the 3, as if it is alphabetic. Ridiculous. I'm going to teach it a lesson by putting it through something. Substitute everything all the way up till Yeah, well, nothing you can do about it, I suppose. M1 equals space, nothing. And then we sort it. And then I put it back. Substitute the beginning with M1 equals, because ik laat me niet klein krijgen, dat is stom. There we are. No, we are still not there. Oh, my SID went wrong. I forgot to put the dot star here. Unbelievable. Unique, yes. And then we can put it back. I just insisted. I didn't grow up. What is this? Being nasty to other people. Right. 12 is still 1, and then... And 6 is still 0. And 18 is still 2. Well, it looks like a classic case of having to divide by 6. Yeah, I did. I didn't be nice. What if I subtract 1 and then divide by 6? That should work. Definitely works. So totally it. Subtract 1 divided by 6. M1 minus 1 divided by 6. Does modulo have a higher precedence than multiplication? I guess not. So my whole code was wrong. What? No, because I wasn't really looking at this line when I was figuring that out, I guess. Int r1 equals m1 minus 1 divided by 6, and then we use the modulo of that. And then I can use r1 here as well. Phew. I think. And if not, then anyway. Now it ends on 3 zeros, which I didn't want. So something is wrong. It did not work. Well, at least R1 is okay. So yeah, here we have a repeat of 1, 2, 3, 4, 5, and R1 equals 5, and here we have a repeat of 1, 2, 3, 4, and R1 is 4. And if we scroll up a lot, then at some point somewhere, if YouTube isn't going to complain about the bandwidth that I'm using with all this scrolling. I think here we are. Here we go from... No, it didn't work. Painful. So I'm not detecting my repeat correctly, apparently. This is where you wish you printed more. The only thing that's changing here is M2. The repeat is almost true. I just borrowed 1 from it. There was a 1 borrowed here. I guess almost is good enough, isn't it? I'll just get negative binary values, but I can work with that. Let's assume that it is still 4. And now here it becomes really 3. But there's actually... Okay. Yeah. Well, yeah. Okay. As in, you know, the 2 of these, 1 of these, and then at the moment that there is 0 of them, I don't really care, actually. I suppose I don't. I mean, I don't know. But at the moment there are 0, there's a chance that we borrow, which then happens right here. So for now, I think I'm just ignoring that, and I think that my repeat should be this. Because it's, you know, like almost exactly okay. I'm not sure.